we shall solve more problems, exercises on double angle identities. So were you able to prove the double angle identities yourselves? Well, I bet you were. And I bet you were kind of happy to obtain these identities yourselves using the sum of angles identities for cosine, sine, and tangent. Use the double angle identities to evaluate the following functions. Find the exact values of sine of 2 times theta and cosine of 2 times theta, given that cosine of theta is equal to 5/13 and theta is greater than 3 pi over 2 but less than 2 pi. Let us get the value of sine of 2 theta first. So sine of 2 theta is among your identities. You have a double angle identity for this, and it's equal to this. Sine of 2 theta is equal to 2 times cosine of theta times sine of theta. Okay, so we already got this. Cosine of theta is 5/13. But what about sine? Okay, so I think you now have some idea about how to get sine. You will use your Pythagorean identity, okay? Your identity which says, but you know what's going to happen. Along the way, you must choose what sign to use. When I mean what sign, are you going to use the negative value of sine or the positive value of sine? And so it is here where this information is going to help you. So this means that our theta is in this second quadrant right here. Not second quadrant, but in the fourth quadrant. So this one is the fourth quadrant. And you know that the terminal point of your arc, whose terminal point ends in the fourth quadrant, is going to have a second coordinate that is negative. So we will choose the negative value of your sine. So we will now solve for sine of theta. We will use this identity, okay? This is your Pythagorean identities. So sine of theta is equal to, again, you will use the negative square root of 1 minus the square of cosine of theta. Okay? And then, what do we do next? Well, we just substitute. We already know what is cosine of theta. It's given. It's 5/13. So do you know how to simplify this? And what I do to simplify this is I write 1 as 169 divided by 169, and then I just copy this. And it's easier to simplify this because you know that when the numerator or the denominator is the same, you will just copy it. And then 169 minus 25, what is that? That is equal to 144. Okay? And so you will get the square root of 144 divided by 169, the negative square root. And it's going to be equal to negative 12/13. So we already have a value for cosine. It's already given. It's 5/13. And we already have a value for sine of theta. It's negative 12/13. So sine of 2 theta is equal to this. 2 times 5/13 times negative of 12/13. So 13 times 13 is 169, okay? And then 2 times 5 is 10, times 12 is 120. But of course, this must be negative. How about cosine of 2 theta? So we just obtained sine of 2 theta. What about this? Cosine of 2 theta. we can use this double angle identity because we already have a value for cosine of theta. It's 5 divided by 13. We have a value for sine of theta. It's negative 12 over 13. Okay, so this is just a simple case of substitution. Okay, so this one is equal to